Okay, next I'm going to talk about what does this look like inside the OBI repository. Okay, it's relatively straightforward. This first slide here will actually help to kind of lay it all out a little bit. At the bottom we have our base tables, right? And here I'm using employee and our workforce event month fact table, which is snapshots and events from HR Analytics. So what we can actually do in the RPD is we can link the table in the lower right, the monthly fact table, up to the skinny dimension that we created for the employee. Okay, and remember it uses the same exact row width, so that's a freebie. You just draw a line and map the table source into the dimension. Okay, well, let's build a skinny fact, moving up into the performance layer, a skinny fact. Well, the skinny fact, it has the employee width, so it can use the employee base table. Okay, it can also use the employee skinny table. Now, if we do this right, we can also set it up so that it can actually use the employee mini dimension table. So now that skinny fact can be used by all three different kinds of tables. And OBI, one of its strengths is it'll know that the mini dimension is better than the skinny dimension, and the skinny dimension is better than the base dimension. OBI is smart like that if we tell it the right things. So it will always use the most optimal technique or tables to solve the query. And then finally, at the very top, for our very high-level aggregate, we actually have whatever aggregate we think we need to support our requirements. But the key here is it would actually link into the mini dimension. And remember, the mini dimension is highly summarized. So those top two tables, when used together, that's where a lot of your extreme performance can come from. Okay. The three fact tables are mapped just like any aggregate tables. There's no difference in how you would do this as to adding any kind of aggregate. And so you see at the lower right, we have the base fact table. Right? It's I've only shown one dimension here, but it's at the employee details level. The skinny fact is also at the employee details level. Remember, it has the same row width, so it has to be at the details level. Now, just between those two tables there, you're saying, well, gee, wait, it's at the same level. Well, the reality is it's not, because your skinny fact is going to have far fewer dimensions than your base fact. Particularly in the BI apps, where a base fact table may have 20 to 40 different dimensions, your skinny fact may only have 7 or 8 or 5. And so OBI considers that automatically to be an aggregate table, which means it's going to be preferred. Technically, it's not an aggregate, but OBI and aggregate navigation considers it to be the same. Right? And then finally, we have our aggregate fact table at the top. And there you can see it's not at the details level anymore. It's at the mini dimension level. Okay. A couple things on how we map the dimensions. Right? So here's one little trick we actually have to do. So we map in our skinny dimension. Now, if you recall, the granularity at the bottom there is identical. Employee details for both of them. Right? So OBI says, hey, wait a minute, these two are equally good. Well, this is where we have to use priority groups. And we set the priority group of 0 is the highest priority, and anything lower than that is a lower priority. So given the choice, it will go ahead and now use the skinny dimension table as opposed to the base dimension. And that scenario only occurs for fields that exist in both. Okay, a field that only exists in the base table, the skinny dimension is not even considered. Okay. The dimensional aggregates. Okay, this one's a little bit more interesting. There's a little trick we have to do here, right? If we think about what we threw into our dimensional aggregate, it was just a bunch of fields, right? A bunch of common fields. They could have come from multiple different hierarchies. Well, if it comes from multiple different hierarchies, the grain is really arbitrary. So that's what we do. We create an arbitrary grain, an arbitrary level in our hierarchy. We just call it mini dimension level. We map all the fields to that level, okay? And then we look at our table sources. We're going to set those the grain, the content tab, to that mini dimension level for both the dimension table as well as the fact table. Okay, so now it knows that there's a higher grain that it's going to actually use for the mini dimension. We don't need to use priority groups for this at all. Okay. I know I went through that kind of quickly, but in reality, the table mapping is relatively straightforward. Again, the facts were just like any normal aggregate. The skinny dimension, all you had to do was map it regular and set that priority group. And then the mini dimension, you just had to do that arbitrary level. Okay. And what we want to do is we want to link these tables across so that OBI can pick the best combination of tables, the fastest combination of tables. So that in one case you may pick the fastest, but you drill down, it may pick the second fastest. You drill down again, it may have to pick the base table. So everything's covered. It's just you're going to be optimizing certain cases.